So almost every one of us has interacted at some point or seen the fog machines at parties or plays or concerts or magicians even. So did you know that the material that is most commonly used to produce this fog actually has a lot to do with Martian climate change? Most fog machines actually use solid carbon dioxide, which is more commonly known on Earth as dry ice. The fog that they produce is just the same carbon dioxide changing directly from a solid to a gas in a process called sublimation. Now on Earth, solid carbon dioxide can only survive at very low temperatures of less than 109 degrees below 0 Fahrenheit. So naturally, since our planet is obviously much warmer than this, the solid carbon dioxide, or the dry ice, is instantly sublimated when it's exposed. And that's where we get the fog for our fog machines. Elsewhere in the solar system, however, solid carbon dioxide can survive for a longer period of time. One of these places where carbon dioxide can do this is Mars. Now, Mars has an atmosphere that's almost entirely composed of carbon dioxide gas. Now, during winter at its poles, the temperatures get so low that the carbon dioxide from the atmosphere can actually condense, that is, transform from a gas directly to a solid on the surface, and form large caps of dry ice that cover almost the entire polar region. When summer comes around at one pole, the carbon dioxide on the surface, the dry ice on the surface, starts to sublimate and goes back into the atmosphere and is deposited up onto the other pole where it's winter at the time. Now, the south pole of Mars is actually very special. It has a 25-foot thick cover of dry ice that survives this summertime sublimation and is there permanently. This so-called residual cap is unlike any other place on Mars and is covered with large circular pits and depressions and holes that make the whole cap look like a giant slab of Swiss cheese. And in fact, parts of the cap are actually called Swiss cheese terrain. So these holes and depressions are actually growing with time currently at an incredible rate of about 9 feet per year. So this tells us that at one point, Mars had to be cold enough to support a large dry ice cap permanently on its surface. And its climate has changed in a way that it's now warmer, and this cap is actually disappearing. So at the current condition, it will disappear in less than 100 years. So now that sounds a little bit familiar, huh? Polar cap retreat, global warming, climate change on Mars. There you go. So scientists currently have a unique opportunity to study the effects of this climate change on Mars as it happens, and even compare the climate conditions on Mars, the climate system of Mars, to the more complicated system on Earth. And this can tell us a lot about global climate change, or planetary climate change in general, and it can maybe even yield important clues and important insights that can help us solve our current climate change predicament, which, unlike on Mars, we've kind of had a little bit of a part in. Thank you.